What's going on, guys? So today we're back and we're going to start looking at how to build a question answer brain in the fight against the coronavirus. This is very applicable and can be transferred to machine learning techniques for the headlines for stock predictions. But essentially, we're probably going to have two streams on this channel, anyways. One stream is going to be for improving the world and useful tools, and one stream is going to be for making money and funding those ideas. So why don't we just jump right into it? So the first step that we need to do, and this particular video is about, is actually extracting the sample size for each one of the clinical trials. And the reason we want to do this is it actually gives a good weight on what documents or what studies to select the best answers from as we're finding the sentence similarities in a question answer system. And as always, in the description is the GitHub repo and the Colab notebooks with all the pertinent data that you'll need to follow along yourself. So what our focus is going to be is we're going to be training a logistics classifier based on regression techniques. And it's going to first go through all the sentences and classify them, and then we'll use another technique to parse those sentences in order to pull out the exact values. So why don't we just jump into it? So the first thing, as always, we're going to do is we're going to be starting by loading all the libraries we need. So some of the important ones here, we're loading the Spacey pre-trained models because their tokenizations give good input for any medical terms that might apply. And then a lot of the other ones are some that we've seen before, such as scikit-learn. And we're going to be using, well, eventually the one versus rest classifier, but for now we're just using the logistics classifier to show you how to train one model, or one group or classification. So we've gone through that installation now. We're going to pull in the data from the repo. So this repo, which is linked in the description, has all the data along with all the training scripts if you ever need it. So we can just go ahead and run that. It doesn't take long and it brings the data over into our Colab. So we can see it's in there now. I'm just going to move the attributes data out because that's what we're going to be training on for today. And we're just going to load it up and take a look. As always, you want to kind of take a look at what the values are and if there's any missing values. Now this is engineered data for our particular training purpose. These are a number of sentences that have already been classified. So feel free to look at the repo for how they're classified if you want to add any more. So once we've done that, we can do the typical train test split of the data. So we can see we've done that now. Now we're actually going to go through, we're defining the pipeline. Because it's words, we're vectorizing it. And then we're going to be running it through the classifiers. So we can see here the accuracy that the actual model is saying is 90%. The real world accuracy we'll have to take a look at through back testing. It won't be that high, and we'll take a look at some of the kind of corner cases as we go through. But for now, we've got a very simple model, and all we've done in this model is give it a bunch of sentences. The pipeline actually vectorizes most of that, and we actually take that and have already classified it in the training data. So now that we kind of have that model ready, we just want to demonstrate how to save it. So we are showing our perhaps our developers for implementation how to save it and how to load it, and then some simple inference just to show how it works. So we can see it's made a number of predictions here. So for our particular case, we're looking at sample size. So all of the final ones had sample size. So we can see there are some errors in here to be expected. And also some sentences have been classified that just aren't don't have the sample size. So we'll definitely have to take a look at that to understand kind of the error rate a bit better. So to do that, what we're going to do is we're going to just look at adding some typical libraries that I've used on, or typical functions that I've used on other projects. We're just going to define them here so that we can use them later. So now that we've done that, we're just going to run it on the full model. And what this is doing is basically outputting all the sentences that weren't correct during training. And, during inference on the training. So it's actually going right back on itself to understand how well it understands from the actual training data, because we know the answers to those. And typically we want to have some holdouts to do a bit more realistic testing of the actual accuracy. So we can see it's going to go through, it's finding all the sentences now that do not really match. So it's actually going through all of them and just telling us what it picked out. So like in our particular case, like results 9, seems like it's a bit incorrect. But what we can see here is just all of the sentences and where the numbers have pulled them out. Now that we've kind of got an idea of some of the errors in that, we can go through and actually in this document, you can see that I've reviewed them and kind of come up with the corner cases and then give a path for improving the training. Now we've particularly gone back and already kind of improved this. So I don't want to go and do that all again and discuss it. But from here, what you can do is you've actually got a model now with a pipeline that automatically does the vectorization and the sentence classification. So you'll just in the code need to do tokenizations. And then you can use the actual clinical trial attributes that are extracted in order to pull out the real world data. And you need that data for, well, for our particular purpose, we're building Westworlds Rehoboam. We're going to have a brain. We want the brain to only answer via the sources that have, the right methodology, the right design, and the most number of participants as well. So that's probably it for today. Hopefully what we've seen here is kind of how to use vectors in word, machine learning, NLP problems, how to train a logistics classifier for regression, and how to apply it again back against your particular data in order to produce usable results that you can then implement in a production environment. So hopefully that was helpful. If you have any questions or comments, feel free to leave them in the comments area. And if you have any suggestions for other videos you'd like to see, just let me know. Thanks again.